Hello everyone, welcome to my class. In today's class, I'm going to cover polar coordinate system. Let me start the class right away. In polar coordinate systems, in this diagram, it consists of the following. A fixed point O, we call pole or origin, which is here. A half line starting at pole and extends horizontally to the right, called the polar axis. So this line starts from pole and extends to the right side. It's also called a ray or half line. So also the polar axis. The polar axis corresponds to the positive x-axis. Let r is the distance of a point P from the pole, and theta be the angle between the polar axis and the line OP. Then every point in the plane can be represented by the order pairs r and theta. R is distance, theta is direction. And r theta are called the polar coordinates of point. Let me move on. We use the conventions that theta is positive if measured in the counterclockwise direction. So this way is positive theta. The points negative r theta and positive r theta lie on the same line through pole and at the same distance r from origin. So that means, so the point r theta is here, minus r theta is in this directions, somewhere here on this line, and they are the same distance apart. The distance is r. Also note that minus r theta represents the same point as r theta plus pi, so polar representation is not unique. So here minus r theta is a point which lies somewhere here. Then this angle is also whole is pi and plus theta. So that means from polar axis the angle of point minus r theta is theta plus pi. I hope this makes sense to you all. That's why the polar representation is not unique representations. Great. Now let's move on. The conversion formula, we can convert the polar coordinate to Cartesian coordinate and vice versa. We have this formula. So in this diagram here, here's a x-axis, here's a y-axis. So the point is pxy. We can also call this x-axis as a polar axis, origin as a pole, and then we have the point, the p, representation in terms of r and theta is simply pr theta. Then we have x equals to r cosine theta on this right triangle. X is r cosine theta, y is r sine theta, square and add them, it becomes x square plus y square equals to 1, and divide the second equation by the first, it gives us tan theta equals to y over x. So we have this polar form. Now we convert to Cartesian form. We have this Cartesian form and we convert to polar form by putting x equals to r cosine theta and y equals to r sine theta. Now let's move on. Now the polar curve, the graph of polar equations is called the polar curve, and this equation is of the form r equals to function of theta, or more generally bring this f theta to the left and this becomes function of r theta equals to 0. Quick example, r equals to 2, r equals to 1 plus sine theta. Awesome. Let's talk about the symmetricity in polar coordinate. So the polar symmetry, the polar curve can be symmetric with respect to either the pole, the polar axis, the vertical line, theta equals to pi half, or none of the above. So there are two ways to check for the polar symmetry in each case below. Let's talk part A, symmetry about the pole. So symmetry about the pole. If the equation is unchanged when r is replaced by negative r, or when theta is replaced by pi plus theta, then the equation is symmetric about the pole. Let's move on. Part B, symmetry about the polar axis. if the equation is unchanged when theta is replaced by minus theta, or theta is replaced by pi minus theta and r by minus r. So here's either replace theta by minus theta or theta by pi minus theta. The pi minus theta angle is this side, and take minus r comes again this side. I hope this makes sense to you all. Let's move on. C. Symmetry about the vertical polar line theta equals to pi half. Is this the theta equals to pi half? If the equation is unchanged in either case 1 and 2, when theta is replaced by pi minus theta, so the point is here, then replace theta by pi minus theta is here, or r is replaced by minus r and theta by minus theta. So first theta by minus theta comes here and replace r by minus r goes there. Great. Let's move on. Remark, the circles r equals to 2 for every theta between 0 and 2 pi is symmetric to all of the above three cases. Great. Now let's talk about sketching the polar curve. The idea, make an r theta table. First pick theta values and then find the corresponding r values. Find the polar intercepts. The polar axis intercepts occurs when theta is multiple of pi, and the vertical polar line theta equals to pi half intercepts occurs when theta is an odd multiple of pi half. Find the maximum value of r. If for some theta r equals to 0 implies that the graph approaches to the pole along the polar line theta equals to at that value. Plot r theta values in the polar coordinate grids. Next, let's talk about polar coordinate grids. So the polar coordinate grids, it contains a series of concentric circles extending out from the pole. So it's a pole, this is the polar axis, so and then it has this concentric circles here. So this angle is polar axis, the angle is 0, and then pi 6, then pi 4, then pi third, then pi half, pi, 3 pi over 2, back to 2 pi. I hope this diagram makes sense to you all. Let's move on. Tangents to polar curves. So in the polar curve, we regard theta as a parameter and write the parametric equation of the curve as x equals to r cosine theta and y equals to r sine theta. So then let's take the derivative with respect to theta and use here the product rule. So dx over d theta, so left side dx over d theta equals to right side dr over d theta, keep cosine theta as it is, then r, then the derivative cosine theta turns out to be negative sine theta. Similarly, dy over d theta becomes dr over d theta times sine theta plus r cosine theta. Then the slope is dy over dx equals to dy over d theta all over dx over d theta. So then put these two values here, which turns out to be dr over d theta times sine theta plus r cosine theta all over dr over d theta cosine theta minus r sine theta. Note the slope at the pole means put r equals to 0, so these two terms disappear, so we only have these terms, and dr over d theta cancel, then sine theta or cosine theta becomes tan theta. Great. Now let's move on. Let's do some example. Example 1. First, let's plot the polar coordinates and find the corresponding Cartesian coordinate. So given coordinate is 2, 3 pi over 2. So here r equals to 2, theta equals to 3 pi over 2. So let's begin the solutions. So here, if you plot this point here using r and theta, that means r is, first let's plot the theta here. Theta is 3 pi over 2. It's here, and go r equals to 2 unit, 1 unit, 2 unit. So that's the point. And let's convert this point to the Cartesian coordinate. So we use x equals to r cosine theta, y equals to r sine theta. So here r is 2, theta is 3 pi over 2. So x equals to then 2 times cosine 3 pi over 2. We know cosine 3 pi over 2 is 0. That means x equals to 0. Y equals to r sine theta. Put r equals to 2, theta equals to 3 pi over 2. We know sine 3 pi over 2 is negative 1. So then 2 times negative 1 turns out to be negative 2. So our point in Cartesian coordinate is 0, negative 2, which makes sense here, right? I hope this makes sense to you all. Great. Now let's move on. Example 2. Sketch the polar region given by r between 1 and 3 and theta between pi 6 to 5 pi over 6. Great. So in the polar axis here, so theta equals to pi over 6, theta equals to pi over 6, theta equals to 5 pi over 6, and r equals to 1, and r equals to 3. So this shaded region is the required region. Awesome. Let's move on. Example 3. Identify the curve by finding the corresponding Cartesian equations. So given polar equation is r equals to 5 cosine theta. Now let's write these polar equations into Cartesian equations. Solutions. We know in polar equations always x square plus y square equals to r square, the conversion formula. So to apply that formula, let me multiply both sides by r. That's a small trick here. So the left side is r square equals to 5 times r cosine theta. We know r square is x square plus y square, and 5 r cosine theta is x. So now we have x square plus y square equals to 5x. Let's rewrite this one. Bring 5x to the left side. Then this becomes x square minus 5x plus y square equals to 0. Then by completing this square, here we have x square minus 5x plus the magic term. Here this magic term is the coefficient of x divided by 2 and a square, and add these terms both sides, y square as it is. The next step, this 3 terms gives me the binomial x minus 5f square and plus y square as it is equals to 25 over 4. Hence this equation is the equation of circle of radius 5 and center at 5 0. I hope this makes sense to you all. Great. Let's move on. Example 4. Find the slope of the tangent to the curve at given point. Given curve is r equals to 2 cosine theta and given point is theta equals to pi third. Begin the solutions. Here we know x equals to r cosine theta, y equals to r sine theta. So in the next step here, r equals 2 cosine theta, so 2, and then cosine theta, this cosine theta is cosine square theta. Take the derivative, dx or d theta turns out to be negative 2 sine 2 theta. We know sine 2 theta equals to 2 sine theta cosine theta. So here we break down 4 into 2, 2. Then 1, 2 is here, 1, 2 is 2 sine theta cosine theta turns out to be sine 2 theta. That's another trig identity. The next, y equals to r sine theta. So r is 2 cosine theta, so this becomes 2 times cosine theta sine theta. So this is simply sine 2 theta. Then take the derivative. It turns out to be dy over d theta equals to 2 cosine 2 theta. Awesome. So the slope is dy dx equals to, by formula, this turns out to be here, which is 1 over radical 3. I hope this computation makes sense to you all. Now let's move on. Let's do example 5. So now this time let's sketch the polar curve given by r equals to 2 cosine theta. Let me bring this up. So let's check first symmetricity. this curve is symmetric with respect to polar axis, since replacing theta by negative theta turns out to be the cosine minus theta equals to cosine theta, so it doesn't change. So it's symmetric with respect to polar axis. For theta equals to pi half, r equals to 0, that means the curve approaches pole along the vertical polar line, theta equals to pi half. So theta between 0 to pi gives a complete circle. Note that it's periodic with period 2 pi, but if we let theta bigger than pi, we obtain the same points again. Okay. So now make an r theta table here. That's better. So put theta equals to value between 0 and pi. Here are the values. Compute the corresponding r values. R equals to 2 cosine theta, and make order pair r theta and plot the point r theta here. So then it gives me the circle center at 1, 0, right? And radius is 1. I hope this table as well as this sketching of the circle makes sense to you all. Now let me move on. Let's do part B here. Given equation is r equals to 1 minus 2 cosine theta. So let's check for symmetricity here. Here's a polar axis, symmetricity. This is a polar line, theta equals to pi half, symmetricity. This is the symmetricity to pole. Let's check the criteria here, all of these criteria. So first, for the polar axis, we replace theta to minus theta. So replace theta to minus theta. It turns out that r equals to 1 minus 2 cos theta, the curve itself. So it passed the polar axis symmetricity. Let's check to the polar line symmetricity. We put r equals to minus r and theta equals to minus theta. Then our given equations changes. That means it fails the polar line theta equals to pi half symmetricity. Let's go to the pole symmetricity. We change r to minus r. Change r to minus r. Then minus r equals to 1 minus 2 cosine theta. So this gives me the different equations. So again it fails the pole symmetricity. So then the given equation is symmetric about the polar axis. Great. Now for theta equals to pi third, the r value is 0. That means the curve approaches to the pole along the polar line theta equals to pi third. Great. So more or less we have the idea. Now let's move on. Again, this is periodic with period 2 pi, but by symmetricity, it suffices to evaluate for theta between 0 and pi. So that's better here. Oh yeah, that's better. So let's make an r theta table. Put the values of theta between 0 and pi, compute the corresponding r values, and make order pair r theta and graph those points in the polar grid here. This polar grid is provided to you. So for example, theta is 0, r is negative 1. Theta is 0 here, we are negative 1, we are here. And let's say theta is pi third. So pi third, our value is 0. So as pi third, value is 0 here. And let's say at pi half, value is 1. At pi half, this is value is 1. So this forms this nice curve. Great. I hope this makes sense to you all. And we have the special name of this one. We call this is a, I think this is a Lima cone. So in general, if r equals to a plus minus b cosine theta, then this is a horizontal shape. If it is r equals to a plus minus b sine theta, this is a vertical. So what I mean by horizontal and vertical, for example, r is horizontal. R is a plus minus b here. So a plus minus b, a is 1, b is 2. So this is a cosine theta constant, so it turns to the left. and I also have this minus sign here. If it is plus, then it turns to the right. So that means here it's just turning to the left here. I hope this makes sense to you. Great. Now let's move on. If these two values a and b are equal, then this gives me the heart shape we call cardioid. If a is less than b, then it produces the inner loop. The inner loop means this one. Great. If r is a, then this is a circle with radius absolute value of a. For example, r equals to a cosine theta or a sine theta. That is a shifted circle with a diameter a. Rho's, the equation is of the form r equals to a cosine n theta or r equals to a sine n theta. If n is odd, we have n many leafed rho's. If n is even, then we have 2n many leafed rho's. For example, r equals to cosine 2 theta. So here is n is 2 even. So we have 2 times 2 is 4 many leafed. For example, here r equals sine 3 theta, n is 3. So we have total 3 many leaves here. And in the first one here when theta is 0, this gives me cosine 0 is 1, so we are at 1 here. And at theta is pi fourth, then 2 times pi fourth is pi half, cosine pi half is 0. So then at pi fourth it again back to its origin here. Great. So we finish these sections. Thank you all.